Alright, let's hook you up with some homework help here in section 5-3. 5-3 with factoring can get a little bit bumpy, so let me try and sort through some of the ones that can give you some problems. Now, if you watched the 5-3 video, you saw me extensively go over all of these that you see here in terms of factoring polynomials. Okay, I love the fact that when you look at this one here, the very first one that they show you is factoring out the GCF. That should always be the first thing you look for, no matter which problem you're being asked to solve by factoring. Okay, so when we look at these problems here, understand that not a single one of this little subset of these numbers I cut here, not a single one of them can be solved by starting off with greatest common factor. Okay, not one of them. So what we're going to do instead is look and see if we can see any clues that can tell us what we can do with the other ones. Now, I think this little chunk I assigned question number 11 and question number 14. So I'm going to help with question 11 in this video, and in a separate video I'll help with question number 14. Okay, because they're two different types of problems here. So to help you understand a little bit more about question number 11, we're going to do 10 and 11 together so that way you can see the difference between the two. Number 10. Number 10 is called can be factored, if you look carefully at it, as a sum of two cubes. Okay. Number 11 is going to get factored as a difference of two cubes. Notice the small differences between the two when you get factored. Notice the plus signs and minus signs when they factor as their first step. So that's one thing I'd like you to point out here first. So let me help you with number 10, which I know wasn't assigned, but let's go ahead and try this problem here. To factor a sum of two cubes properly, step 1, understand what two things got cubed to give you x cubed and 64. That's what's going to go right here in this first little set right here. So x cubed and 64, well, I know x times x times x gives me x to the third, and 4 times 4 times 4 gives me 64. So I can write that in there, x plus 4. And then, from there, the other part, this second chunk right here, a lot of students make a big mistake and they still try to figure out what goes in these three terms because they're still looking at this guy right here. Don't look there. Instead, just look at what you just factored here. You factored this into x and 4. So getting these other three terms here can all be found by what you just wrote down here with the x and the 4. Let me show you something here. Do you notice that if we have a here, all they want you to put right here is whatever a is, just square it. So if this is x, which is playing that role of a right there, just square x, and there we go. We have x squared, followed by minus sign. And then AB, what that means is just multiply the a and the b together. So in this case, the a and the b is the x and the 4. We don't write x4. Let's write 4x. And then after that, we write in b squared, which if b is 4, then b squared would be a positive 16. That is step 1. Now, I would love it if we could just stop right there, but unfortunately, these problems are asking us to find solutions, right? Not just stop by factoring, but find solutions. In other words, they want to know, hey, when is this equal to 0? Well, based off of the work we've done in previous units, we know that when we have stuff factored, like we have here, polynomials or quadratics, whichever ones we're working on right there, we can come up with one of those answers pretty easily. And one of those answers that we have to have comes from this guy right here, right? We have two things being multiplied together. We have x plus 4 times x squared minus 4x plus 16. So one of those two factors has to be 0. So why not let's get the easy one there. How about that red one? Wouldn't that mean that x plus 4 could be 0? And when we solve that problem, wouldn't we get one of our answers just to be, when we subtract 4 from both sides, that x needs to be equal to a negative 4. So there's one answer to number 10. Now the other answer comes from this other guy here, this other factor in yellow. Now you got good news and bad news. The good news is that to solve that other factor when you do a sum or a difference of two cubes, the good news is it's the same move every single time. You will never do any other, there's no variety of moves here. There's only one way out of this. Okay? The bad news, the way out of this, has to be the quadratic formula. You have to use it. You will never find a number that will multiply to give you this c value here of 16 and add to go to give you that b value there, in this case of -4. So let's set up that quadratic formula. So there once again is a reminder of our quadratic formula. We have a is 1, b is -4, c is 16. Quadratic formula you see right there. And now your next step is doing all the substitution work. So then we substitute those in, keeping in mind that the opposite of b in this case would be a +4. Get your -4 squared minus 4ac, all divided by 2a. Remember, your primary job here to simplify this correctly is just figure out what that is right down there. Don't do anything else, okay? Don't square root that. So it looks like to me we have 16 minus 4 times 1 times 16, I think that's 64. So 16 minus 64, I think that's -48. So now we put that -48 in here, and a couple things jump out at me first and foremost. Number one, do you notice that this number, the discriminant that we have here, is negative, which means I'm going to have some imaginary solutions here. Other thing that I'm seeing here is that we have 48, which is not a perfect square, so mentally what I'm doing is I'm running through all of those perfect squares. It's 5 times 5, 6 times 6, 7 times 7. I'll stop right there because 49 is higher than 48. Remember the other little trick you can use. You can even take that that number that's not a perfect square, cut it in half. So any number that's more than halfway there. Hey, look at 16. I think we can break down 16. 16 times 3 would give us 48. So now we can factor that guy, that -48. So we'd have -1 times the +16 times the +3. And so then I can take the square root of -1, I can take the square root of 16, right? And so then what we'd end up with here this time is we'd end up with our 4 plus minus. The square root of 16 would be this 4 that you see right here, and the square root of -1 would be the I, and then the square root of 3, and that's all divided by 2. Here's another little trick that you need to know how to do. Because some people will get here and they'll say, Mr. Cook, I don't see that answer in the back of the book. The reason why you don't see this answer in the back of the book is because they reduced the fraction. If I have two 4's up here separated by that plus-minus sign, and they're both being divided by 2, well, I can divide each one of those by 2. So one answer that I will get here would be x equals 2 plus 2i square roots of 3. See how I did that? This 4 divided by 2 gives us this 2 right there. Back, back, back. And then this 4 divided by that 2 would give us this 2 right there. Back, back, back. So we don't have to worry about any simplifying there. And then the other answer that we'll get here, simplifying the square root, I should say. And then the other one should be the negative case, okay? This will have some major implications later when we start talking about the fundamental theorem of algebra. So, there's our three answers there that we just saw by factoring, okay? Let's set up number 11. Alright, so let's look at number 11. X cubed minus 1,000 equals 0. Well, first job that we should probably worry about here is factoring x cubed minus 1,000. So now this one is a difference of two cubes. Now, do you notice how a difference of two cubes gets handled a little bit differently than a sum of two cubes? Instead of a plus b, now we're going to have a minus b. So what we can put here for our first factor would be x followed by minus 10, because x times x times x is x cubed, and 10 times 10 times 10 would give us 1,000. Now what about that second factor? All we need to do is look at x minus 10, and that can give us the rest of these three terms in that second factor. So there we go. We take a look right here. Let me scroll down here a little bit so that way you can still see everything. X squared plus 10x plus 100. See why that needs to be a plus? Look right about here. See how that's a plus sign there now. Okay, so that's why we have plus 10x squared. Okay, so then the easy part, once again, we have x minus 10 times this other factor here of x squared plus 10x plus 100. That part there in blue, very, very factorable. So we go ahead and factor that. well, I'm sorry, let's not factor that, I mean solve it. Set it equal to 0, so x minus 10 needs to be equal to 0, so that means we have one solution here of x equals 10. Now the other solutions are right there in yellow. We got to use the quadratic formula on that, so let's set that up. So there we have that. A is 1, B is 10, C is 100. Substitute that in there. Remember, next move, 100 minus 4 times 1 times 100 would be 400, so 100 minus 400 would take us to negative 300. Alright, so then our next move is factoring that negative 300. Well, it's going to be an I in it, and then thinking of a perfect square that would go into 300, well, first one that comes to mind to me would be 100. I mean, 100, 10 times 10, and wouldn't that be 100 times 3? I think we've got the biggest perfect square because there's no perfect squares that go into 3. So let's go ahead and factor negative 300 into 3 factors, one of them being negative 1. And then we'd have times 100 and then times 3. So now I can take the square root of the 100, take the square root of negative 1, so that would give us negative 10 plus minus, that would be what, 10i, times the square root of 3 divided by 2. Next move, let's take both of these two negative 10, or that negative 10 and that positive 10, that plus minus 10, and divide each one of those by 2. And so that would take us to this quantity right here of negative 5 plus minus 5i square root of 3. So then we'd get two more answers here. One answer would be our negative 5 plus 5i square root of 3. And then the other answer, negative 5 minus 5i square root of 3. So I hope that helps a little bit with the sums and differences of two cubes. Spoiler alert, on test day, I'm not going to have you guys do factor sums or differences of cubes. So don't stress out about that too much other than just the homework. I want to see you practice on the homework, please.